All right, 1315, surface area of pyramids and triangular prisms. So 1314 dealt with prisms. We also did cylinders. We'll put that aside for the moment here. But what is a prism? What is a pyramid? What are the differences between the two? I'll tell you here that once we finish this, our last three lessons, we're going to switch gears. We're going to focus on the concept of volume, the last three, which is different than surface area. Volume measures capacity. Think like a fish tank. The surface area would be all the sides, the glass. But the volume is how much liquid goes into that fish tank if I filled the whole thing up. So volume is like what's inside of a three-dimensional figure. Volume is quite a bit easier to figure out than surface area. So you'll find the last three lessons easier than these surface area lessons. They're not quite as deep. We'll cover them next week here, but we'll be shifting gears a bit. Not Monday. We'll do that quiz on Tuesday. So that's when we'll do our next lesson here. But the last three lessons after today, again, we're shifting gears again here. Volumes represented with a different label and all that here. But we're still on surface area. Basically 2 days of surface area is what it is, and today's day 2. So contrasting pyramids versus prisms. There's two fundamental differences between a pyramid and a prism. First, any prism has congruent bases, and any prism is named by what their base is. So we dealt with rectangular prisms, and again, when I was holding up the box, I kind of showed you I could turn it this way, this way, this way, this way. It's hard to really identify what's the base of a rectangular prism. Just you can turn it any way and stand it on any side, and its top and bottom can be just whatever way you flip it around. But a triangular prism, 4, 5, and 6 are triangular prisms here. How do I know they're triangular prisms? Well, 1, 2, and 3 are pyramids. And again, most people understand the pyramid has the pointy top to it. That is true. That is true. That is one characteristic of a pyramid. A pyramid only has one base. Prisms have two. And you can see these are triangular prisms. How do I know? Well, I see the bases here, the top and the bottom, they are triangles. And how do I know they're the top and the bottom? That brings me to point 2, the difference between a pyramid and a prism. The sides of a prism are always rectangles. Always. That's a characteristic of a prism. So notice that these all have rectangular sides. Depending on what type of polygon forms the prism, we dealt with rectangular ones, so they're going to have 4 sides. Triangular ones are going to have 3 sides. You can kind of see it here of 1, 2. You see these here that they got their 3 sides going on here. If I had a hexagonal base prism, well, that would have 6 sides. That would all be rectangular. We're not going to see those in any of our years here, but when you get to high school, you will. There's no real limit to any polygon can form the base of a prism or a pyramid. There's no difference in that there. So prisms are named by their bases. Rectangular base prism, triangular base prism, hexagonal base prism, octagonal based prism. But the sides of a prism are always rectangles, and a prism always has 2 bases. A top and a bottom are congruent to each other. These triangles are the same. All these triangles are the exact same size and shape. Okay? A pyramid has sides that are triangles. And you can see these are all triangles here. Here in 6th grade, we're only going to deal with square-based or officially rectangular-based triangular pyramids. But once again, a pyramid can have any polygon base. You could have an octagonal pyramid with an octagon base that would just have 8 triangles that all fold in and make a point on top. There's no limit to it's got to have at least 3 sides, but it could be a triangle base, a rectangle base, any polygon base here. But here in 6th grade, we're only going to have square bases, and that makes it a little easier for us. Next year, though, we'll have some other ones. We'll introduce rectangle and triangle bases on your pyramids to you. So those are the 2 fundamental differences. How do you know what's a prism? How do you know what's a pyramid? Prisms are defined by their bases. They have 2 congruent bases that are polygons, and their sides are rectangles. Pyramids have 1 base, a polygon, but their sides are triangles. Okay? So that's how you know what you're looking at here. That's, again, plus visually here, we know what a pyramid looks like, but again, look closely at the sides here versus the sides of this guy here. You can see that the prisms are rectangles and the pyramids are indeed triangles, but the bases could be anything. In this case, for the pyramids, the bases are squares, but for the prisms, the bases are triangles, right?
Right.
So same general concept that we talked about yesterday, that if I look at number 1 here, when I'm finding surface area, what am I trying to figure out? Well, I need to figure out the area of this base here on the bottom, but I also need to figure out the area of all these 4 triangles here. Basically, there's 5 different faces, or sides, I guess you could say, but faces is a better word when you're dealing with 3-dimensional figures going on. There's a bottom, and you can see there's 1, 2, 3, 4 sides on this pyramid. That's 5 total figures. The base, which is a square, plus the 4 triangles mean there's 5 different things going on here. Agreed? So our surface area is going to be, once again, the sum of all 5 of those polygons. The area of the square plus the area of the 4 triangles. So we're only dealing with square-based pyramids this year. All right, emphasizing that one more time. So let's look at number 1. There's no real great formula to give you here. Instead, I'm looking at number 1 here. And
It's really easy.
it takes a little practice.
Oh, it does? I did it first try.
So there we go. So 7 meters, 7 meters, and then you see kind of here this red line. It's telling me that's 9 meters. I see a right angle symbol going on there. Again, I'll go back to the book here. It's just me recreating. One more time back to the book. But I will tell you for both we'll just stick with the pyramid, but all 3 of these numbers have a very distinct and important value to us. When we get to these prisms down here, once again, every single number you see has a purpose. There's no extra information being thrown at you here that's like, oh, I don't need that number. Kind of like we talked about perimeter and area, and sometimes with triangles especially, a side length versus a height type of deal. So I need to find the area of 5 different things, and you can do it in either order you want, but I'm going to choose to start with the base. Okay, the base is what it sits on. The base is a square. Yes?
Yes.
So how would I find the area of the base here? What is the area of the
7
base?
times 7.
Which is
49.
meters
Squared.
squared. Right. So I'm going to do the area of the base, which happens to be a square in this case here. And I see a square, length times width, 7 meters times 7 meters. That gives me 49 meters squared. Okay. I'm just going to save that number for the time being here. I'm going to need it in the end though. Okay. Now, let's look at the sides. So, when we're dealing with a square-based pyramid, what we know to be true is all 4 of the sides are going to be congruent to each other, meaning they're going to be the exact same triangles. All of these triangles are the same. What do I need to know to find the area of a triangle?
The base.
The base?
And the height.
What's the formula to find the area of a triangle?
Base times height.
Area of a triangle.
So she wants to know if she should pause Hannah and Charlotte's test or suspend it.
Are you guys done for now?
Yeah.
Base
She should suspend them.
Okay.
Yes.
No, that's pretty low.
What's the formula to find area of a triangle?
1/2 times the base times
Right.
the height.
1/2, because remember, it goes back to a triangle is half of a parallelogram, right?
Yeah.
We remember showing that to you earlier on this year. Triangle's half of parallelogram, base times height. So there's my formula. So I do need to know two things, base and a height. So all four of these triangles are the same. So to find my area of the triangles, I want to say the area of the sides, which are triangles. But all four of the triangles are the same triangle. What is the measurement of the base of each triangle?
9. I mean, wait, 7.
Right here, 7 meters. What's the height of the triangles?
9.
9. And I know this to be the height. How?
Because 9 is a right angle.
Is pointed to the.
You said it at the very
Right
end there.
angle.
Right, you gotta have the right angle symbol, right? The base and the height always form a right angle with a triangle. Otherwise, I mean, again, when we get over here, we got more numbers. We got 3 inches, I got 2 inches, I got 2.5 inches. What's what? And how do I know? And again, it goes back to what we talked about here in this lesson, that the base and the height always will form a right angle with each other. Always. Always. So this right angle symbol is very important for what we're doing here, because without it, we don't know if that's truly the height of the triangle or not. The height and the base always form right angles with each other. Always. You should suspend.
Yeah, I know, but I can't,
Make sure to save your.
okay, but
Yeah,
wait a
you
minute. I can't get up to suspend. It says I have to pause it first.
Well, yeah, first you pause.
Yeah. And then I have to go to, and then go to here again. Yeah, there.
Select there.
And then suspend. Oh, X that out, because that, right here, just X it out,
Yeah, you can see that
because
there.
it came the first time.
Be
Pause.
able to pause there. Students must be following for pause testing,
Okay.
which they are.
Yeah,
So I don't know why it's not. I would think if they just let it be here, but,
suspend.
well, it's not gonna do it because it still says it's in testing mode. I don't know why it's not refreshing here. Let's refresh yours here. But you should just be able to move them right to pause here. Oh, there we go.
Okay.
And now, we should suspend. And then when they bring it up here, again, you wrote this
No,
in.
not terminate.
No, I'm not doing, I'm just pointing, I'm saying, you got this written down, right?
Yeah.
Because you'll have to bring that back, have them log in, just like before here. But what will happen is, you'll bring them up, you'll have to have them test, you'll
Yeah.
confirm them and all that. But when they go up, you'll have the option, it'll say, do you want them to start over or continue where
Oh,
they left
no,
off?
continue.
And, yeah, it's the same thing when I had Kana's situation.
Yeah.
Suspended, had her log in, and then it gave me a choice. Do you want to? And I asked her. I said, "Do you want to start the thing over or continue?" And she's like, "I want to continue." I go, "That's fine." But you'll see that option then when you come back to it here.
So should I end session?
You can
Yeah,
end
end
this.
it, but then when you do that, end, press that.
Yeah, or you can just leave it
Oh,
alone here.
can't test
But
anymore today, so save and exit,
yep,
because there's just no more time.
yeah. No, I get you there. I get you. So
Buckets,
we're all
I'm
good
getting
here.
old.
We're all good here. So, but yeah, just save that session key and password, and then you'll be able to fire it up again. Okay.
What? Testing it started.
Back on track. So anyway, talking about the triangles. So what I'm saying here, when I write my formula, it is 1/2 times the base times the height, but I'm gonna modify it also slightly because similar to like the prisms here, I don't need to figure out each of these triangles 4 times. They're all the same triangle. They all have a base of 7, and they all have a height of 9. That's a characteristic of a square-based pyramid. Other pyramids will be different, how we got to go about doing it. But for our purposes today, all I really need to do is find the area of one of the triangles and then multiply that answer by 4. Right. So times 4. And I'm doing that because I'm finding the area of one of the triangles, whatever that area happens to be. I'm just going to multiply that number by 4, and that'll tell me the area of all 4 of the triangles in one shot here. So now, plug in what I know to be true, 1/2 times the base, which is 7 meters, times the height, which is 9 meters, times 4. I won't write this down, but if you're smart and seeing what's going on here, rinse, wash, and repeat, 1/2 of 4 is 2. So really what I'm doing is multiplying the base and the height times 2, right? Because 1/2 of 4 is 2, right? You see what I'm saying here?
Yeah.
So if you want to think about it that way, again, it's not officially correct, and I'm not going to write it down that way, but what's really going on is the base times the height times 2. And this only works for a square-based pyramid, though. Only this approach here. But that's all we're going to see this year. Okay? So whatever and however you choose to go about thinking about this, I'm just going to do it just like this. But 1/2 is the same as 0.5 times the base, which is 7, times the height, which is 9. So one triangle is 31.5 or 31 5/10 meters squared. That's one triangle. But since there's 4 of them, I'm just going to take the area of 1, multiply it by 4. My 4 triangles have a total area of 126 meters squared. That's all 4 triangles. No, that's not the answer. That's the area of the triangles. So then to find the total surface area, all I need to do is add the area of the base, which was the square, to the area of my 3 triangles, or 4 triangles, and add my 49 to that. The final answer should be 175 meters squared.
Oh, so we take the area of the triangles times the area of the base?
No, we just add them together.
Okay.
Right, we're adding, we're not multiplying. It's the sum of 5 different figures. The triangle 1, 2, 3, 4, and then the square. Just like we did with the rectangles, we added essentially 6 numbers together, but we realized we could multiply by 2, and we basically just really added 3 numbers together then. We added. But it's the area of the base plus the area of the sides. Find the area of the base, save that number, find the area of the sides. Add those 2 numbers together. That will give you your surface area. That is the area of the square plus triangle 1 plus triangle 2 plus triangle 3 plus triangle 4. All 5 polygons areas are represented inside that 175 meters squared. Does that make sense?
So, yeah. So a formula could be 1/2 times the base times the height times 4 plus the area of the base.
That's exactly correct.
So
Yeah. And if you want to write it out that way for yourself, and that's the way you want to remember it, everything you said is spot on there. Right, spot on. You guys can write things however you want. It's your notes. It's your notes. If there's a way, guys, shh. If there is a way that you are seeing things or understanding things a little differently, if you have questions for me about what you're seeing, what you're thinking, I am here for you. But you are right. All right. So why don't you guys try number 2?
okay, I'm gonna do number 2 so good you won't even know how good I'm gonna do it. Think you're not gonna do it.
So 11 centimeters. 11 centimeters. 9 centimeters. Find the surface area of the pyramid. I'll give you a minute here, and then I will take a little poll. And then I will work it out. And then we got to move on to the prisms. So there it is there. It's easier to look at that.
Oh my gosh. I forgot to do it time before.
That's okay. Just think about doing this if you didn't have your calculators with you this chapter.
Yeah, say that. This chapter would have been like bad.
Find the surface area of the cylinder without a calculator. Yeah, you see why you get your calculators now?
Yeah.
Right, yeah.
It's kind of takes some getting used to use.
Yeah, I know. Well, yeah, it'd be.
Why did we learn math our whole life when we're using a calculator?
If you can do more stuff in your head, then you're freed up to focus on higher level things here. Again, punching, like if you have to punch 2 plus 3 into your calculator because you're so tethered to just, you have no confidence in any ability, well, that's slower. You're not really thinking, and you're focusing on what's 2 plus 3 when you should be solving some more complex equation. So the more you can do in your head, the better it is. It frees you up to do other things here. It frees you up to do other things. So it's just, I mean, understanding how these things go together, because again, we're doing higher level stuff now. If you don't understand how to add and things come together and what they're going to look like, well then you're going to have a really impossible time trying to understand higher level concept if you don't understand the basics of math and only have a calculator to do anything for you.
Are we ever gonna use like these letters?
Some of them.
I can't even.
Okay. If you want to volunteer and answer, cool.
319 centimeters squared.
Okay.
I got 319 centimeters squared. I got 319 centimeters squared.
319 centimeters squared. 319 centimeters.
Okay. So it sounds like, anybody else have anything different?
Damien.
Everybody has something different.
So, here we go. Quickly, okay, I gotta move quick. The prisms are tricky. So, I'm gonna find the area of the base, which is the square. And to do that, I take the length times the width, base times the height. 11 centimeters times 11 centimeters is 121 square centimeters. All right, and I need that number. I'm going to just put it aside, though, for the time being. Now, area of the sides, which are triangles. And there are 4 of them that are all the same. So 1/2 times the base, 11 centimeters, times the height, which is 9 centimeters. And then I'm just going to multiply that by 4 because I have 4 sides that are the exact same triangle. So I just find the area of one of these triangles, and then I'll just take that and multiply it by 4 because all 4 triangles are the same. So 99 doubled is 198 centimeters squared. And of course, one triangle was 44.5. That's one triangle. And I'm just multiplying that by 4 because all 4 are the same. That's where my 198 has come from there. But I found the area of one triangle. 1/2 times base times height. Half of 99 is, no, it's 49.5. My bad. 49.5. And then multiply that times 4 gives me my 198. So now, to find my surface area, it's the sum of the sides, 198, plus the area of the base, which was 121. 198 plus 121 is 319 centimeters squared. That is correct there. Okay. Okay, we got to move on here. Number 4. So now we're shifting gears. We're going to look at the triangular prisms. I'll do my best to sketch it here for us.
A rectangle, a triangle. Oh. Oh. I screwed up.
Okay. So, a lot of different numbers going on. Pay attention, please. And stop. Let's try and quiet down a little bit here for this part. A lot of numbers in play here. And every single one of these numbers has a purpose. So, again, what do we got going on here? How many different sides are there to this thing?
3. 5.
There's 5.
Oh, I thought you meant. Oh.
There's a top and a bottom, which are two congruent triangles. And then there's 3 sides that are rectangles. 1, 2, 3. See them all there? The 2 triangles that are the top and the bottom. And then the 3 rectangles. 1 here, 1 here, 1 here. Now, you can go about solving these any way, but once again, I need to find the area of all 5 of these things. And then basically the sum of this triangle, this rectangle, rectangle, rectangle. That's my surface area. So the area, the sum of all 5 of those polygons, some are triangles and some are rectangles, added together. Let's start with the base, which is a triangle. And I know that's to be true because 1, the bases are congruent, and 2, the sides are rectangles. So I know the triangles are the base. The thing is sitting on its side. All right? This one's standing up and down on its top and bottom, but the sides are always rectangles. All right? The bases are congruent polygons too. So that's how I know. This one's just sitting on its side. Huh?
Bases have to be congruent.
Yes, in a prism. That is correct. In a prism. A prism, just like a cylinder, the only difference between a cylinder and a prism is cylinders have circular bases. Prisms have polygon bases. So, but they're similar in that regard though. They have congruent bases. So pyramids and cones are similar as well. We don't cover cones this year. Next year we'll cover cones. We'll introduce cones and find surface area of them and stuff. A little bit different, but 8th grade then we'll introduce spheres. And they're also different.
I don't know how.
Well, again, don't worry about it. So, let's start with this. Basically, what I need to figure out is the area of the bases. Okay? And they are triangles. So, I know both the triangles are the same. So, once again, the formula to find the area of a triangle, 1/2 the base times the height. But this time, I'm going to multiply by what in the end here?
2.
I'll multiply by 2 because that'll give me the top and the bottom. Those 2 triangles are the same. So if I look at my triangle here, 1/2, what is the measurement of the base of the triangle?
Measure of the base of the triangle. Wait,
So it would be
3 times 4. 12. No.
One more time. Go back to what I've talked about over here about the relationship between the base and the height. What do you need to know?
Oh,
I've said it over and over here.
the right angle. 5.
What do you need to know to find the base and the height of a triangle?
The
right angle.
The right angle. So that's what I'm trying to hone in on here. The base and the height form a right angle. Which of the measurements there provided, you see the right angle right there, right? You see it right there and you see it right there. Which of those 2 numbers are forming that right angle? What is the measurement of the base of the triangle?
3.
3 inches. What is the height?
2.5. No, 2.
2. Oh,
2.
Yes.
2.5 is a side length of the triangle.
Yeah, I didn't see that.
The numbers you need is the 3 inches and the 2 inches. The 3 inches is the base, the 2 inches in red pointing forms this line. Those are the two figures that make my right angle. So that's the base and the height. The base is 3 inches, the height is 2 inches.
I thought the bases had to be congruent.
They do, they are congruent, because there's another base back here.
Yeah.
This triangle right here. This triangle is identical to this triangle, though. This one also has a base of 3. This one also has a height of 2 inches. They don't need to write it in there because by definition, prisms have 2 congruent bases. We don't need to write all that information over here too. It would just get really congested with numbers all over the place if they put this and that. I mean, every single one of these things here, there would be 15 different numbers here. How would you find any of the information with that many numbers in this amount of space?
So it would be
But
7.
there's certain properties of the prism that I talked about at the start here that are true. This triangle and this triangle are the same triangle, which means if this one has a base of 3 and a height of 2, this one also back here has a base of 3 and a height of 2. They both do. So I'm figuring out the area of both of these triangles here. This one right here and this one back here. So in a sense, 1/2 times 2 just cancel each other out. The area of one triangle is 3 inches squared. The area of both the triangles is 6 inches squared. So if I write it out, triangle 1, triangle 2. 3 inches squared and 3 inches squared. All right? So there we go. We got the area of the bases there. Okay? Now, off to the sides. How many sides are there?
5.
4.
No.
There are 3.
10.
3 sides.
3.
Well, there's 2 bases and 3 sides.
Yeah, because
Sorry about that. The sides, I mean, this is the top and the bottom. This is the top and bottom, and these are the sides. Over here, the thing is sitting on its side. So there are 3 sides going on here. They are all rectangles. So I got rectangle 1, rectangle 2, rectangle 3. Okay? So now, let's kind of go through this here. Let's talk about this one right here. Go back to my sheet. This one right here, right in the front here. So what's the formula to find the area of a rectangle?
Base times height.
Right, area equal, there you go, a rectangle. So this rectangle, this one right here,
4.
what am I multiplying together?
2.5 times 4.
Right, 4 inches times 2.5 inches, which is how many, which is what?
10.
I believe so. So there's one of them. Okay. Let's look at this one in the back now. This one right here. See which one I'm talking about? This guy right here. What's its measurements? It is the same. So it's also 10 inches squared. Now, this one on the bottom here, this one. What's its measurements?
10. Same? No. 3 and 10 for the base.
What are the two numbers I need to multiply? This one's different than the other
Length
two.
and the base.
Huh?
3 inches.
The length and the base.
The one on the bottom. It is 4 inches this way,
Oh, 4 and
but
3.
this one's a 4x3 rectangle.
Oh,
You see it here? This one's 4 inches. The same base of the triangle is the same side of this rectangle down here, right? This one on the bottom is a 4x3 rectangle. The one on the front, 4x2.5. The one on the back, 4x2.5. The one on the bottom, though, is 4x3. It's not the same as the other two. So that one is 4 inches times 3 inches, which equals 12 inches squared. Okay? So now, there they are. There's my 5 different, the front triangle, the back triangle, or you can just do it all at once here. All right. And ditto with some of these sides here. You got to be very careful though, but due to how they do these triangles, you're going to run into the same scenario where two of the three rectangles will be the same, but one of the rectangles will be different. They won't all be the same. All three of them will not be the same rectangle. Two of the three will be the same. Okay?
Is there a formula?
No, there's no real formula here. There's
There's
nothing.
a formula for the area of the base though, right? It's 1/2 times the base times.
It depends on, in this case here, they're triangle bases, but these are prisms, but these were rectangles. So how you find the area is dependent on what type of base you even have. It goes back to what we talked about with area. You need to use the right, what type of polygon is it? If it's a square or rectangle, base times height, or length times width. If it's a triangle though, it's 1/2 times base times height. So the formula that you're using is dependent on what type of polygon you're looking at. And again, in future years, we'll incorporate trapezoid bases and stuff. And then we got that formula to deal with too, on top of the others. Down the road, not this year, don't get stressed. We got enough we're trying to figure out at the moment here. But the formulas that you use, it's not set in stone because it's dependent on what type of base and sides you have. In prisms, again, it could be any polygon, but the sides will always be rectangles. In a pyramid, again, it could be anything on the bottom, but the sides will always be triangles. So you'll need to know rectangles, triangles. You got to be able to identify the sides, the bases. Are they triangles? Are they rectangles? You got to be able to identify the sides. Are they triangles or rectangles? And then use either the rectangle formula or the triangle formula, depending which one you're doing. Right?
Yeah.
Okay. So then, of course, to find the surface area, in the end, I would add these three values up. 32 plus 6, the final answer would be 38, right? My bad. 38. 38 inches squared is correct there. Okay. Why don't you guys try number 5? This will be our last one we can do here. So I will walk through it.
What?
I will walk, well, it's 10:25, so almost so. But I would like you to try, I will walk through the whole process in a minute here. If you don't get it all, if you get, that's fine. But see what you can do. What did we talk about? What do you know to be true? What can you figure out? What measurements are what? All this stuff here. I'm not saying it's the easiest thing in the world. No, but I will walk through the whole thing. I'll give you about 2 minutes here.
There's like too many steps.
Okay, I'm gonna start going. If you're still working, that's fine, but I'm gonna represent my information this way. I'm just gonna show you each of the 5 pieces. There are some shortcuts, I suppose, like especially with the triangles, you can just double this number and things like that, but I wanna show them each to you one at a time. So I'm gonna start with the bases, the triangles. So 1/2 base times height. Of course, there are 2 of them. I could multiply by 2 and get just this in one number, but I'm just going to do it one at a time. So 1/2, the base is 6 feet, and the height is 4 feet. I know that to be true because the base and the height always form a right angle in a triangle. So that's how I know those are the numbers I want, the 6 and the 4. So one triangle then, half of 24, is 12 feet squared. But you may write down 24 feet square and just tuck that number aside. But both triangles are the same.
Let's go, that's what I got.
Why am I writing them down
I
there?
got the base area is 24. Yeah, for both
Well, yeah,
of those.
that's the sum of both triangles there. So you could certainly just figure it out once, multiply it by 2, and come up with 24 feet squared, and then tuck that number aside. Here, save it. So now we're on to the rectangle sides here. So first, I'll start with this one over here. All right, this one is 12 by 5, which is 60. And this one over here is also 12 by 5. So there's the one I could, again, double, and maybe you did. If you just wrote the 120 over here, you know, if you just wrote this number, 120, and tuck that number aside, that's fine. Those are the 2 that are the same, but the one on the back is, again, still height of 12, no issues there, but right here, this is that third rectangle right here. 12 by 6. And that one is 72 feet squared. That third one there. The base of the triangle also forms the side of the rectangle, right? The base of the triangle is also a side of one of the rectangles, right there. One of the rectangles, 2 of the rectangles, 3 of the rectangles. 1 rectangle, 2 rectangle, 3 rectangle. All the rectangles have a height of 12 though. 12, 12, and 12. No issues there. But their bases are 5, 5, and 6. So then here's my numbers I should have here. 20, or I'll just done. 216 feet squared is what you would come up with in the end.
So how do you find the mini, like the triangles, the mini thing?
You're looking for the right angle, always looking for the right angle symbol. And then you're trying to lock in what are the 2 measurements that make up, because you see that right angle touches the 6 here, and it also touches this dashed line where it's that 4 feet is pointing at it. So that's how I know those are the 2 measurements, because the right angle will literally touch the 2 sides or the 2 measurements that you're looking for to form the base and the height. And the height, of course, is not a real measurement of anything on the thing, but it's a key number to find the area of the triangle. It's not a side of the triangle. The triangle sides are 5, 5, and 6. But the one that we matter, because you got a 5 here and a 5 here, but those 2 5s, they're not forming there's no right angle here, there's no right angle here. The right angle is formed with this one right here. that make sense? You can see literally that red box touches this line right here. That's how I know, that's one of the numbers I need. That box is literally touching this line right here, and that line is 6 feet. That's how I know that's the right base there. And then the height is that dashed red line with the red arrow, and it's kind of points at it there. So generally speaking, your heights of all these different triangles will be the numbers with the red arrow pointing at it. Those are your heights. They make it a little more explicit for you. All these arrows and all 6 of these here are pointing to the heights of different triangles.
So you do things we all do is go like this and smell your meter like
Times 1/2.
oh,
But then you're multiplying by 2 because the one on the bottom is the exact same triangle. Also has a base of 6, also has a height of 4. So in a sense, the 1/2 and the times 2 just cancel each other out. And then you're just left with 6 times 4 in the end there, but it's actually 1/2 times 6 times 4 times 2.
I get it.
Okay.
I have your notes.
Yeah, give that Damien.
Thank you.
You're welcome, sir.